Hello children. So in the last class we have seen what is potentiometer. So potentiometer, to deal the type of questions, all the type of questions that is coming in potentiometer, we discussed a new approach, okay, which is nothing but our focus will be mainly on potential gradient. So I will revise it today. So before doing this question, we'll have a quick recap. So this is a driving cell. Driving cell means which makes this circuit working. This cell, this is the cell, or here only we connect which circuit, the circuit of which we need to find the potential. Galvanometer is there, so galvanometer is connected. Generally we will be moving this jockey so that no deflection in the galvanometer will come at a point where balancing length we get. That is this potential and this potential when it is same. Okay, potential between this point, potential between these 2 points or these 2 points. When they are same, the things will be balanced, no current will be passing through this. The potential difference between this point and this point, potential difference between this point and this point will become 0. Okay, and this cell, we are not going to find the voltage of this cell. Okay, this one is to drive the circuit, so this one we call driving cell. What is potential gradient? Suppose if this is AB, potential gradient is VAB divided by L. Okay, this length is what is L. Okay, that is voltage per unit length. Voltage per unit length. This is what is potential gradient. So potential gradient K, and if we find this length as X, K into X will be equal to this voltage, whatever we are going to find, E by 2 or whatever it may be, E by 2 or maybe sometimes E, sometimes V, whatever it may be. So all the questions we will be focusing on this idea, potential gradient into that length. Which length? Balancing length will be equal to this voltage. Correct or what? Okay, so this is the idea we are going to do. How much will be the total voltage across this? What will be VAB? VAB is going to be potential gradient into the full length. This voltage is nothing but potential gradient into this length. This voltage is potential gradient into this length. This potential is nothing but potential gradient into that length. Okay, so whatever be the distance, any point we can find the potential or potential difference or voltage by doing what? Potential gradient into that length. Okay, then how we found potential gradient? Potential gradient can be found by using this formula, that is this voltage divided by this length. So how to find this voltage? The current passing through this into this resistance. Okay, V is equal to IR. So once if you understand the concept of potentiometer, then remaining all the things are our basics on circuit. Till now, if you have studied well, you will not find any difference problem here. But till now, if you are not studying well, if you do not know V is equal to IR, how to solve a circuit, then you may find it difficult. So that what we should do, if we find it difficult in the basics of circuits, then we should revise the things and come back. Okay, so I repeat, this voltage equal to this voltage is equal to potential gradient into this length. Okay, what is potential gradient? This voltage divided by this length. Okay, then how to find this voltage? Current will be flowing through this, no current will be flowing here because we have kept the jockey in the balancing length, so current will be flowing. So when current flows, I into this current into this resistance is what is VAB. Okay, the voltage across that length of the wire. Okay, so with this recap, we will continue solving problems. Okay, now certain problems, 2 problems I think we have solved in the last class. So today we will continue doing problems, and different types of problems are there. Okay, now our task is simply one cell will be given. We need to find the question given here. Let's see. A potentiometer wire AB of length L and resistance 12R and resistance 12R. Okay, so 12R is given here, so we'll mark here 12R. Okay, so this is the resistance. Okay, let us put it here, 12R. Okay, this is the resistance. Okay, joined to SL D. This is what is D. Okay, this is also given in the question, D. This figure is given in the question. D of EMF E and internal resistance R. So this is driving cell. We know the circuit of potentiometer, basic circuit of potentiometer. So this is the driving cell. So its EMF is E, internal resistance is R. Okay, a cell C having EMF E by 2. Okay, see here this one. Having EMF E by 2 and internal resistance 3R is connected. The length AJ at which the galvanometer as shown in the figure shows no deflection. So what is the question? Question is we need to find the length AJ. This is our task, AJ. Okay, and options are given based on this length, 13 by 24 L, 11 by 24 L. Likewise options are given. Okay, so pause the screen and try for yourself. How to try? Again, go back to potential gradient. Simple concept. If you go to potential gradient and if you try to solve, things are very easy. Okay, fine. So pause the screen and try yourself. Okay, fine. Okay, so now I am solving. So okay, so you verify your answer. E by 2 must be equal to what? K into X or K into AJ. This is what we need to find. Okay, so E by 2. Okay, so here that time this, when this galvanometer jockey, when it moves, when it comes here at AJ, the galvanometer current will be 0. Okay, galvanometer shows no deflection. Okay, so no current is flowing. So E by 2 is nothing but equal to Kx. So E by 2 is equal to K into, so this X is what is AJ, right? X is what we need to find. Okay, now what is K? K is VAB divided by its resistance. How much is its resistance? Resistance is, divided by its length L. Okay, K is equal to VAB divided by its length. What is VAB? What is VAB? VAB is I into R. So here no current. If I starts flowing like this, I will be flowing like this. It will flow like this, right? No current here, nothing will enter here, nothing will enter in this side. Okay, so VAB is nothing but I into R. What is the resistance of this potentiometer wire AB? 12R divided by L. What about this I? I is again, okay, let us see separately. I is equal to voltage full. Okay, so that is nothing but only this cell is there. This is inactive, no current here. E divided by R equivalent, E divided by R equivalent. What is R equivalent? E divided by internal resistance R is there plus this wire resistance 12 R is there. Any other resistance is there? Nothing else is there. Clear? So K is equal to, here we will substitute E divided by 13R, this is I, into 12R divided by L. So this R will cancel. This is going to be 12E divided by L. 12E divided by L. Okay, now we will substitute here. We got K. So E by 2 is equal to 12E divided by L into X. Okay, so E we will cancel. 13 is here, no? Okay. 13 is here. Okay. So yeah, 13 is here. Okay, fine. So what is X now? X is equal to 13. This will go here. 12 will come here. 13 by 24. This L will go here. L. 13 by 24 into L. Which option? Option A. Okay. I repeat the answer. See, seems to be very complex but very simple. Okay, just appearance only seems to be complex, but it is very simple. Focus on potential gradient. This, the circuit which is kept for testing, its EMF, or whether if it is a circuit, its voltage. Okay, so this EMF or this voltage will be equal to this voltage. And this voltage is equal to what? What about this voltage? Potential gradient into this length. So E by 2 is equal to K into X. X is what? Balancing length. Fine. Now after that, our task is to just to find the potential gradient K. What is K? This potential divided by this length. VAB divided by L. What is VAB? Current passing through this into its resistance. V is equal to IR, simple concept. So I into its resistance 12R. This L we will put here. Now what is I? V by R. V is this one divided by equivalent resistance. This R, this is series now. This is series now. So R plus 12R. This is inactive. So no parallel, no other problem here. This is completely series. Okay, so E by R plus 12R. E by R plus 12R. We got E by 13R. Okay, E by 13R. So K is equal to I, E by 13R into 12R divided by L. So 12 by 12 E by 13L we got as K. We substitute here. We got the value of X. Clear? Okay, so this question they asked for JEE 2019. Okay, JEE 2019 question, potentiometer. Okay, those who do not know the concepts, it seems to be very tough. But if we approach through potential gradient, everything we can solve easily. Okay, note it down. Take this question, students. So in the circuit shown, this is given, this figure is given in the question. In the circuit shown, a 4 meter potentiometer wire is made up of 400 centimeter long wire which extends between A and B. That is between A and B, 100, 200, 300, 400, 100, 100, 100, 100, 400 centimeter long potentiometer wire. The resistance per unit length of the potentiometer wire is R is equal to 0.01 ohm. That is 0.01 is the resistance of 1 centimeter. So the resistance of potentiometer wire is equal to 0.01 is for 1 centimeter. So for 400, this is going to be into 400. We can say that 4 ohm. 4 ohm, 0.01 ohm per centimeter into 400 centimeter. This into ohm per centimeter. So 4 ohm is the potentiometer wire resistance. If an ideal voltmeter, okay, ideal voltmeter means what? The resistance of this voltmeter is going to be what? Infinite. Ideal voltmeter means the resistance of the voltmeter will be infinite. So ideal voltmeter is connected here, okay, as shown with jockey at 50 centimeter, okay, from end A. The expected reading of the voltmeter will be, we need to find the reading of the voltmeter. So that is indirectly they are asking what is the potential between these 2 points. What is the potential of the 2 points? That is, they are asking VAJ is equal to what? That is what is the reading of the potentiometer. Now here galvanometer, balancing length, all these things doesn't matter. The voltmeter is ideal, so no current is going to pass through the voltmeter at any cost. Simply the question is what is the potential between these 2 points. That is what they are asking by putting the reading of the voltmeter, right? So you pause the screen and try for yourself. Okay, the necessary voltage here, this is equal to what? K into x voltage gradient into that length. Okay, that is the concept here. Okay, fine. So pause the screen and try yourself. Right, so VAJ, this is what they have asked. This is equal to K into x. So x is what? Given 50 centimeter, right? What is K? K is equal to the voltage across this full length potentiometer divided by its length, that is VAB divided by length of the potentiometer wire. This is what is potential gradient. What is VAB? I, the current that is passing through here, there is a mistake. This is 1.5 volt. VAB is the current that is passing through the wire. Okay, I into what resistance? Potentiometer resistance, that is R potentiometer divided by length. This is what is VAB. Now we will find one by one. What is the current? Current will be here, this will produce current. Current will be passing through this. Okay, current will be passing like this. So what is this current value? Okay, I is equal to V by R equivalent, okay, or E equivalent divided by R equivalent. So these both are connected in same polarity. So EMF is 1.5 plus 1.5. 1.5 plus 1.5. What is R equivalent? Its internal resistance plus this internal resistance plus this potentiometer wire resistance plus this external resistance. So 0.5 plus 0.5 plus 4. How much is 4 plus 1. So this is going to be 3 by 6 is equal to 1 by 2 ampere. So current is 1 by 2 ampere. Okay, so what is VAB now? VAB is current into the potentiometer wire resistance. V is equal to IR. VAB is equal to IAB into RAB. Okay, so I is equal to 1 by 2 and potentiometer resistance is 4 ohm. We will be getting 2 volt. This is the potential across A and B. Right. So potential gradient K is equal to what is VAB? 2. Length is how much? 400 centimeter. So voltage across AJ is equal to what? This one, K into X. 2 by 400 centimeter into X is what? 50 centimeter. Okay, so if we cancel these two, this is nothing but 8. So 2 by 8 or 1 by 4 volt. Okay, 0.25 volt will be the answer. 0.25 volt. 0.25 volt is the answer. VAJ. Clear? So this is also JEE question. JEE 2019, I think. Okay, JEE mains 2019. Okay, simple. I repeat, what we need to find? We need to find the reading of the ideal voltmeter. Ideal voltmeter is connected across A and the jockey is connected here. Ideal voltmeter means no current will be passing through this because its resistance is infinite. Right? So this VAJ is what we need to find. VAJ is what? Kx. Always throughout potentiometer Kx only. So whatever we need to find, that is equal to Kx. VAJ is equal to Kx. What is K? K is this full voltage divided by its length. K is equal to VAB by L. What is VAB? Voltage across potentiometer. The current that is passing through that into that resistance I into R potential. So I is equal to, just like a general circuit, we will find I. E equivalent by R equivalent. E equivalent is through two voltages, two EMFs are there, two batteries are there, it's equivalent, same polarity, so I added, divided by total resistance. So current we got. From current we will be finding VAB. Once if we find VAB, we will be able to find potential gradient. So VAJ is potential gradient into that length. Clear? Okay, note it down. Okay, whatever question, okay, just potential gradient into that length is equal to the voltage to be measured. Then after writing that, whatever we need to find, just simple circuit only then. It is going to be a simple circuit, just we need to solve it. Okay. Okay students, now the second application of potentiometer is comparing EMF of two cells. So is it nothing new? Okay, already we know how to find the EMF of a cell using potentiometer. Now if we get one more cell, then we will find the EMF of two cells. That's it, nothing else. So here two cells are given, E1, E2. So first step is to find the EMF of cell E1. So switch K1. Okay, if we close it, okay, if we close it, then what will happen? After that, we will move this jockey through the potentiometer wire, just like we have done so far. Okay, till we get galvanometer deflection as 0. So that length we will measure. Suppose if this is AC, I am taking this as measuring length, that is AC1 is equal to L1. Okay, AC1 is equal to L1. I just moved this. At one point the potential of both became same and current stopped, okay, moving. So AC1 is equal to L1. Now suppose if the potential gradient is K, I can write that E1 is equal to what? K L1. So we know how to find the potential gradient now. Okay, now second process is we open switch K1 and switch K2. Okay, we will close it. Okay, K2 open, K2 is open. Now here K1, we open K1. So again, now this is open, this is closed, this is open now. Now again we will move this jockey, and at one point galvanometer current will become 0 based on this potential. When this potential is equal to this potential, that will become 0, current will become 0. So we will get AC2, this is another length, say this is L2, and potential gradient of the wire is K, same wire only, uniform area, cross section is also uniform. Now what is E2? E2 is equal to what? K L2, K L2. So this is how we will be able to find the EMF of cells. So E1 is equal to KL1, E2 is equal to KL2. So as a matter of comparing two cells, we will be getting E1 by E2 is equal to KL1 by KL2. So K will be cancelled off. Finally, we will be getting the ratio of EMF of first cell to the EMF of second cell will be equal to the balancing length ratio. Okay. So this is nothing new. Only difference is in the previous discussion we had only one cell. Okay, comfortably we were able to find the EMF of that cell just by doing E is equal to Kx. Potential gradient we found, and just we understood what is the EMF of that cell. Even if it is not EMF, if we give any part of the circuit, this V, this potential difference of this circuit will be equal to what? Kx potential gradient into the balancing length. Okay, that is the only thing. So now here the only difference is two cells came. So we will operate one cell, then we will operate another cell. That's it, nothing else, no other difference. Clear? Note it down. Take this question. In figure is given a long uniform potentiometer wire AB. Okay, long potentiometer wire AB with constant potential gradient. Okay, AB, constant potential gradient along its length. The null point for two primary cells of EMF E1 and E2 connected in the manner shown are obtained at a distance of 120 cm and 300 cm from end A. That is, when these cells are connected in this form, E1 and E2, one connection we got the null point. Null point means that galvanometer current is 0, no deflection. We got it 120 centimeter, and another connection we got the null point at 300 centimeter. We need to find the ratio of E1 and E2. Okay, so how to solve this? Okay, so again same concept only. Okay, potential is equal to gradient, potential gradient into that distance, balancing length, same thing. Okay, right. Now here first case we will consider this one, first one. So E1 plus minus plus, so they are connected in the opposite polarity. Already we have spent some time for studying the combination of cells. So same thing here. So first thing is E1 minus E2 is equal to what? Kx, again Kx. This if we connect, if we switch on, we will be getting balancing length at 120 centimeter. This is equal to K into 120 Kx, E1 minus E2. Why E1 minus E2? Because this is difference. Why not E2 minus E1? Why not E2 minus E1? See, I told you in the previous session, the positive of this driving cell must be connected to the positive of the cell where we are trying to find the EMF. This should not be like a same polarity. If it is same polarity, null point we won't get. So definitely this cell must be greater than this one. Okay, and we need to take which polarity? This E1 polarity. That is why I have taken E1 minus E2. Okay, fine. Now we will connect this one. We will switch off this one. So E1, E2, they are plus minus. This plus is connected to this plus. Fine. So they are at the same polarity. E1 plus E2. Where we are getting the null point? We are getting the null point at 300 centimeters. So this is equal to K into 300. So Kx, instead of E is equal to Kx, this time we have taken like E1 plus E2 and E1 minus E2 is equal to Kx. Now if we solve this, we'll get this answer. So if we add them, this is equal to 2E1 is equal to what? We will be getting K into 420. K into 420. So E1 will be what? E1 is equal to 210K. E1 is equal to 210K. So if that is the case, then E1 plus E2 is equal to K into 300. E1 is 210K. So 210K plus E2 is equal to 300K. So E2 is equal to 90K. So E1 by E2 is equal to what? 210K divided by 90K. K and the 0 cancel. 21 by 9. 21 by 9 means in 21 3 7 times, and in 9 it is 3 times. So 7 by 3. So answer is A. Okay, seems to be complex problem, but it is very simple. Clear? Note it down. Okay, so this is first question. Suppose if they ask null point for E1, null point for E1. So instead of all these, just if we connect cell E1 alone, then where we will be getting the balancing length? That is the question. Null point for E1. So pause the screen, try yourself, pause the screen and try yourself. So question is nothing but, we'll remove all this. Okay, just we need to find the balancing length if we connect E1. Okay, we connect E1, we'll be getting balancing length somewhere. So what will be that? What is this X? Okay, so E1 is equal to 210K we got. E1 is equal to 210K we got. E1 is equal to what? 210K. E1 is equal to 210K. Okay, we got it. So now balancing length, E1 is equal to what? K into X. K into X. So if we cancel this K and K, then what will be getting? X is equal to 210 centimeter. Okay, so in this way we can find the balancing length for E1 also. Okay, so two cells, if we compare, so see, I have taken two cells combination. Okay, directly if we put two cells, definitely you will be able to do, because E1 K1 K into X1, E2 K into X2, you will find, you will take the ratio directly. That will not be a troubling problem for you. But if we connect it like this, it is something is there to think, even though this problem is easy. So potential gradient, nothing but EMF is equal to Kx. If we get a circuit that voltage V is equal to Kx, fine, everything is that. Remaining all the things are your aptitude and common sense. Okay, now we can find internal resistance of cell also indirectly, not directly, by doing calculation using potentiometer. That is the third category of problems that we used to get from potentiometer. That also we'll see. Okay students, so now we will calculate the internal resistance of a cell. Okay, suppose if we have a cell, we do not know how much is its internal resistance. While we are going to use a cell in the circuit, and we just want to calculate its internal resistance, then only we will be able to analyze the circuit well. Okay, so already we have seen how to calculate the EMF of a cell. So E is equal to Kx, but that's it, nothing else. EMF E is equal to K into X, potential gradient into X, that balancing length. Okay, now suppose if we need to find the internal resistance of a given cell, so we just cannot do this directly, but indirectly we will do. Okay, just the same concept we will apply. E is equal to Kx, then we will be able to find the internal resistance. Okay, so two steps are there. first we will look at the circuit. First thing is same driving cell, key, rheostat, potentiometer, wire. Now if we connect a cell here with the EMF E, internal resistance R, if we connect this part, then we will be able to find the balancing length and we will be able to find this EMF. So now in order to find internal resistance, the extra thing what we are doing is we will connect a resistance R, that external resistance or shunt resistance we will connect here, and for that also we will be able to find the balancing length. So then we will do some calculation and we will get it. So how to do this step by step we will see. So first process is number 1, this switch, okay, switch S is open, okay, this is now open, okay, switch S is open. So that time what will happen, we will be able to find a balancing length. So if we move the jockey, okay, there will not be any current, Ig will be 0, okay, and we will be able to find a balancing length. So what will be that balancing length? That balancing length will be purely the EMF of this cell, okay, just like E is equal to K into X, this concept only. Okay, now what we will name that length? So let us put E is equal to K into the length which we are getting is LE, that is when only cell is there. So this LE is nothing but the length, the balancing length, only when cell is connected, that is this part is not connected, switch is open. Okay, so current will be flowing, okay, current will be flowing, and we will be able to find the potential gradient also. Okay, fine. So that is the first step. When no current is flowing, this EMF is what is the potential difference across these 2 points. These 2 points also, the potential both will be same. The simple concept of potentiometer which we have seen so far. Suppose if I redraw this circuit in a simple way, this is going to be like this. Okay, this switch is already on. Okay, so suppose if this is A, this is B, potentiometer setup, E0, rheostat. Now here we have connected cell, its internal resistance, galvanometer, jockey. So this AC, this length we have taken as LE. Clear? Only that much is there. Done. Not done. Number 2, switch S is closed. Okay, opened, it is closed. Now what will happen? Switch is closed. Okay, now the new circuit is okay, E0, RH, A, B. Now here, okay, hope I will make a change to this circuit itself. Okay, we don't have space here. Okay, now this is switched on. Now when this is switched on, again we will find the balancing length. Okay, null point here also, null point at LE. Okay, null point at LE. So here null point at, simply we will put as LR, that is when R is also connected. Okay, LR, I am just naming whatever name you want, you can give L1, L2, whatever is fine. Okay, null point we got at LR. That is when this is connected. So again, null point we got at LR. So this is LR. Okay, Ig is equal to 0. Fine. Now this is a closed path. This is a closed path. What will happen? Current will flow through this. Current will flow through this. So now this is connected. Current will flow through this. Right? Okay, current will be flowing through this I. Okay. Other than that, here another current will be flowing here across. Just to avoid confusion, I will name this as IR. Okay, I through this shunt resistance R. Okay, so here current will be flowing through this. Here current will be flowing through this. No current in this branch. So this is one closed circuit. This is another closed circuit. Right. So now E is equal to Kx. E is equal to Kx. So what can we write here? We can say that the potential difference across these two terminals are same. The potential across this wire, potential across this wire, both are same. That is, the voltage across this resistance R is terminal potential difference. This is same as the resistance, the potential across this point. We have studied this while we study about cells. When current is flowing, the terminal potential difference will be there. Okay, that will be same as the potential difference in cell and internal resistance. That is the potential difference across external resistance. Both are same. When current is not flowing, terminal potential difference is same as E. When current is not flowing means open circuit. All these things we have seen. If you have doubt, you must watch that video again. Okay, this is how. Okay, so if we name this as these 2 points as okay, X, Y, this is also same, X, Y. Both the terminals are same. Clear? So the potential across these 2 points, okay, is same as this, what, Kx of this. Potential difference of this is equal to K into X of this. Clear? That is the concept. Now what is the potential difference across XY? Okay, what is the potential difference across XY? This we need to understand. So roughly we will be able to write the voltage across XY is equal to K into what? L in LR. Okay, L suffix R. Clear? That is fine. Understood, na? Okay, now we will find what is this XY, VXY. VXY can be what? Using this also we can find. Okay, just like E minus IR, or otherwise I into R. That is also fine. Both are same. So here I am preferring I into R. I into R. Okay, this is also same. This is also same. Both are parallel. I into R. What is I? I is equal to E by R equivalent. E by R equivalent. Correct? R equivalent of this circuit. So that is E by capital R plus small r. Only that is there in this circuit. So what I do, I need to calculate this internal resistance. So R plus R is equal to E by VXY into R. Now this R is equal to E by VXY into R minus R. Now this R is equal to, if I take R outside, I will be getting E by Vxy minus 1. Okay, this is the internal resistance. Okay, so each term, what it denotes, we must understand. This R is internal resistance of this testing cell. Vxy is the potential difference across these 2 points when then this switch is closed. E is the EMF of this cell. Clear? Note it down. Now we will substitute Vxy and this Vxy is equal to K into Lr and E is equal to K into Le there. Again we will get a formula. I am removing this, erasing this. Okay, so simply internal resistance small r is equal to this shunt resistance, this one, this into E divided by Vxy. Okay, Vxy, remember this circuit. Okay, Vxy minus 1. Now R is equal to R into, what is this, K into Le. This length is when only battery is connected, switch is open. Which switch? This switch is open, that length, divided by K into Lr. This length is when this is closed. Okay, minus 1. So this K will be cancelled off. R is equal to capital R into Le by Lr minus 1. Okay, so this is the concept. Okay, to calculate the internal resistance of a cell. So anything we can put here. Okay, if you want you can put L1 by L2, that is also fine. So your wish. R into L2 minus L1 minus 1. But here just mugging up of formula will put you under trouble. That is the main problem. We no need to mug up. Understand the things and study. Okay, understand the things and study. Even when you remember the formulas, we should have the concepts in the mind. Okay, very simple. Okay, then this is going to be very simple. Nothing. I will tell you the steps once again. Switch is open of this external circuitry. Then this EMF, the EMF of the cell will be equal to the balancing length into potential gradient. E is equal to Kx. So far this is what we have done. Okay, fine. Now switch is closed. When switch is closed, we will take the balancing length again. That is Lr or L2, whatever it may be. Then this potential difference will be equal to this potential difference. So this potential difference, simply take IR. Which IR? This I into R. Clear? So while deriving, I have put here simply I. Don't misunderstand. This is this I only, IR. IR into R. Now you know how to find this I, this E divided by equivalent resistance. Okay, so you can remember this. Simply you can just understand the concept. If the values are given directly, if we substitute here, we'll get the answers. Okay, okay, so K is equal to E is equal to Kx. Outside potential difference is equal to Kx. That is the concept we are using here. Okay, we will do problem also on this. Okay, clear? Note it down. Read this question. In a potentiometer, it is found that no current passes through the galvanometer when the terminals of the cell are connected across 52 centimeter of the potentiometer wire. Okay, so if the cell is shunted by a resistance of 5 ohm, balance is found at 40 centimeter of the wire. Find the internal resistance. So we got, when the terminals of the cell are connected across 52 centimeter, we got balance. Okay, and when a resistance of 5 ohm is connected across shunt, we got at 40 centimeter, right? So pause the screen and try to do yourself. Okay, you know the concept, now you can try. So simply this is the potentiometer wire. Okay, see, this is a driving cell, rheostat, and potentiometer wire A, B. Okay, in a simple terms. Okay, now if we connect a cell, this length they have given as 52 centimeters. So we can write E is equal to Kx, same concept. So E is equal to what? Potential gradient K into 52 centimeter, right? So this is the first case. Second case is, okay, same. Here along with this cell and its internal resistance, we have connected a resistance of shunt 5 ohm ER we connected, and again we got the balancing length at what? 40 centimeter. 40 centimeter. So here what is the internal resistance they are asking? So in this case, this voltage V is equal to what? K into another length, which is nothing but 40 centimeter. Okay, so just now we need to find the internal resistance. So what is internal resistance? R is equal to E divided by V minus 1 into capital R. Now we will substitute these values here. Okay, so R is equal to, what is E? 52K. What is V? 40K minus 1 into external resistance is 5 ohm. K will be cancelled out. 52 minus 40 divided by 40 into 5. So this is going to be 8 by 40 into 5. So this, if we cut, this will become 8, will be getting 1 ohm. Internal resistance is 1 ohm. So easy. It is easy thing. Just understand the approach. This question is 2018 JEE. Okay, mains, right? So I repeat, first we connect this cell, we got the balancing length E is equal to K into 52. Then after that we connected shunt, we got the balancing length V is equal to K into 40. Okay, now internal resistance R is equal to E by V minus 1 into R. Okay, E we substitute 52K, V we put 40K, then substitute. E is also not given, V is also not given, current is also not given, nothing is given. Simply we substituted these things and get the answers. Okay, so I feel like this approach is easiest approach as far as I know. Okay, once if you understand the concept, this approach is easy to apply for potentiometer. Okay, clear? Note it down. So some more information on potentiometer. So this is regarding sensitivity of potentiometer. Okay, what is sensitivity? Simple thing. Okay, just like we know, among our friends, some are very sensitive. What sensitive means? For small thing, very strong reaction. Okay, if we tease someone, they feel so bad, reacting, not able to talk to us. Okay, just like that. When someone comes and says to us like there is no biology exam tomorrow, no biology exam tomorrow, one person will be responding like that, another person will be responding, no biology exam tomorrow. Okay, fine. Bas. So two people, two sensitive nature. So more reaction from the potentiometer is what is sensitivity of potentiometer. Okay, that is for small change in voltage, big balancing length difference. Okay, so it will detect very small change in voltage also. Okay, so small change in voltages, okay, balancing length will be more. That is what is sensitivity of potentiometer. Okay, just read this. Okay, it can measure small potential difference. It shows significant change in balancing length for small change in potential difference. Okay, for small change in potential difference, significant change in balancing length. That is, this balancing length increases for small delta V. For small delta V. Okay, for small changes. And what is this? K is equal to what? V by L. K is equal to V by L. So if K is small, we can say, if K is small, potentiometer is sensitive. Is sensitive, we can say. If K is small, potentiometer is sensitive. Okay, so say for example, if K, okay, so for K I am showing two types of sensitivity. Okay, say for example 2 volt per meter, this is one thing. Another thing is 2 volt per centimeter. 2 volt per centimeter, K, 2 Ks. One is 2 volt per meter. Okay, so for a 2 meter change difference, 2 meter length, for 1 meter length, for 1 meter length 2 volt will be there. Here for 1 centimeter 2 volt difference. So which is more sensitive? Which is more sensitive? See this, K is equal to V by L. So that is, when V increases, K increases. Okay, V decreases, K decreases. Same way here, if L increases, K decreases. If L decreases, if L increases, K decreases. If L decreases, K increases. So easily we will be able to comment on the sensitivity of potentiometer just by observing K. So here voltage is more, so K decreases. Voltage is so K increases. Voltage is more, so K increases. So this is more sensitive. Okay, what about this? This one here, length decreases. Length decreases, so K again increases. So for K is small, when we decrease the length, K increases. When K is small, potentiometer is sensitive. So okay, so just understand the sensitivity of potentiometer. Simple thing is, it just look at K again here, potential gradient. Okay, if K is small, then potentiometer is more sensitive. Okay, K is what? Voltage divided by length. So in that way we will be able to comment on that also. Okay, so hope you enjoyed potentiometer. Okay, so try to collect as many questions as possible, try to solve it. Okay, just V is equal to Kx, just apply that concept, nothing else. Okay, and check whether you are able to crack all the potentiometer related questions. Correct? Okay students, goodbye, good luck.